we are discussing some basic probability theories. One very well-known example is when you toss a fair coin. So the two possibilities are head and tail. And as we assume that the coin is fair, so you will have 50-50 chances, right? Head representing half of the outcomes and tail representing half of the outcomes. So you have equal chances, okay? The first rule is if you add up the probabilities of head and tail, it will sum to 1, okay? And probability of head or probability of tail, the values will be within the range of 0 to 1, okay? So this is true for mutually exclusive events. Again, we follow some notations that the probability of A or B. The addition rule is stating that probability of A union B for mutually exclusive events. So for the example of head and tail, if you sum, it will be 1, okay? Then multiplication rule. So you toss a coin, first one is head and the second one is head again. So here we are talking about mutually exclusive events. That means that the second one is not influenced by the first one, okay? So in that case, you will have first time half and the second time half. You multiply, it will be 1/4, okay? So if you are clear about mutually exclusive event, that one doesn't influence the next event, but we'll see an example where the events are not mutually exclusive, okay? What is the probability of getting a 2 or getting an even number when rolling a fair-sided die? Okay, so here we are talking about throwing a dice, okay? And dice has 6 sides. 1, 2, 3, 4, 5, 6. And the two events we are trying to estimate the probability for is that getting a 2 and getting an even number. So even number can be 2, 4, or 6, okay? In this case, we have a little bit different rule. So probability of A union B is probability of A plus probability of B. Then we have to subtract probability of A and B, okay? Because there is an overlap, okay? Because 2 can be in both sets, okay? So probability of A is 1/6 because 2 is one of the 6 instances. Then probability of B is you have 3 instances of even number out of these 6, so 3/6. And then probability of A and B is 1/6. If you believe in this setup, then probability of A union B is 1/6 plus 3/6 minus 1/6 equal to 1/2, okay? So again, this is for not exclusive events. That means that two events have some overlap, okay? Now, in the last part, we asked you to think about this problem, okay? So you are given some orange and green balls in 2 boxes. One of those is a red box and the other one is a blue box. You picked up the ball and it turned out to be orange. We asked you to estimate the probability that the ball came from the red box, okay? So to do that, you will need to learn a concept what we call Bayes rule. Probability of A given B is probability of B given A times probability of A divided by probability of B, okay? So I suggest that you go through section 1.2 probability theory from the book Pattern Recognition and Machine Learning. I suggest that you put some effort understanding this problem because this will help you to understand this math jargons, okay? Again, here we are trying to estimate the probability of the ball coming from the red box by taking into consideration these 2 boxes. They can be picked equally and each box has their own distribution of these balls, okay? So we have to use this information to answer this question, which is a little bit trickier, but I suggest you guys put some effort and then look at the solution here. Okay, let's try that, and if you have any question, you can reach out to me always.